Now each of that you change now all these to in terms of you can change in terms of either Q actually. So that would be your Q. That what total Q is coming from the tank only. So you can write either Q2 or just a Q. Now F is given by your two correlations. So one is F is you have this actually 64 upon RE. Another one is that one. So this is 1 upon of under root of F. Do you know all of you this thing? ये देखा किसी ने कि नहीं?
Yes, sir.
हाँ,
Yes,
so
sir.
you have
Yes, sir.
minus 1.1, you have log here, and inside the bracket you have epsilon upon d. So you have here 3.7, I think here 3.7 or the
Yes,
Yes,
sir.
sir. Yes, sir. Yes, sir.
yeah, so here 3.7 and this whole to the power 1.1, right?
Yes, sir.
So yeah, then plus you have 6.9 upon RE. So
Sir, it's not
6.9.
in the power. 1.1.
Huh?
1.1 is in power.
That I'm changing.
Okay, sir.
So this is this one. So this is being used when your RE is, let's say, uh,
Sir, also, sir, it's minus 1.8 log.
where 1.8 log.
Yes, sir, minus 1.8.
1.8 or 1.1?
So 1.8.
Okay.
1.8.
So okay, fine. So you have this. So if this is case for RE less than equal to, let's say you can say 2100 here, and rest of the case you have this. So from these you will calculate your actually your F. Before that, what you need actually your RE. So RE need to be calculated. Do you know any one of the you know the expression of RE?
dV rho by mu.
Rho VD by
So
mu.
yes, so dV rho by mu actually. Now this you can convert this into the flow rate. So if you want to convert into the flow rate, what can you write for that? So V would be the Q by A, right?
Yes, sir.
So you can write here Q and area is pi by d4, right?
Sir, also in the head loss equation that you have written above, it should also be Q
हाँ
by.
yeah, वहाँ भी change करना है. Just wait.
Yes, sir.
Yeah, so this would be actually your pi d by 4. D square would come here. So this is you have changed this into the in terms of Q. Same thing here. Also, same thing would go at this particular place also. So this place also, this would be changed by same thing, and this whole thing to the power your 2 actually. Okay. So you are converting this into in terms of flow rate, Q also in terms of the flow rate, and then you have the F here. Correct?
Yes,
Yes,
sir.
sir.
Now, one thing. So let's begin. The first part is just to calculate how much is flow rate is coming out. Fine. So for that particular part, you what variables you have? Only thing you have the unknown. Either you can take Q or calculate your F, or take your F, calculate your Q. Right? That is the thing can be been the done only.
Yes, sir.
Correct.
Yes, sir.
Yes, sir.
So first you can start from the, let's say you can start a for loop here. So first you can start a for loop for this. So let's say you have taken for loop for I equal to and let's say आपने Q का ही loop लगा दिया और let's say I लगा दिया, let's say I आपने 1 and you are changing by 1, let's say आपने you can take maybe 10,000 and all that. I don't know how much time bullet are run actually, so I can put its any value. Now let's say I am starting my Q equal to, let's say, least possible one, this one. This is just the starting. We don't have idea. You have calculated Q already, right? कितना Q calculate किया आपने? Q max you have calculated already.
16.78.
16.78.
So you have calculated Q max. So you already have a value of Q max. Q max कितना था? How much?
16.78.
16.78. So that's what your Q max. So you can say on the safer side, maybe okay, you can take that also. No problem. Now you can generate your I. So you can generate your this here, the size of matrix A. Let's say you want to change this Q from here. Each interval, let's say you want to change by 1 and you want to raise by value of 16.78. So it will just generate your all values of Q. This command. This the step size is in your hand actually. Either you can change maybe a 0.01 or you can start maybe a 0.001 flow rate. You already have this value, so obviously your Q would be not that much low, which you are the starting here 0.001. So that's not a point, right? Practically you may the start from, let's say, 0.01. So 0.01 meter cube is okay, is quite low value, or maybe in that starting you can start maybe 0.1 meter cube per second. In variation also you can also take maybe this is the your choice. Maybe you can take a variation of 0.01 or maybe 0.1. 0.1 would be a too fast actually, so you can take maybe 0.01. Okay. So that
Yes,
way
sir.
this Q vector would be generated. Now here you can have a command now. This would be a length of Q now. It will automatically count that how many elements are there in this by this command length of Q. So it will first this Q command would generate all values between 0.1 to 16.78 and it will have a all generated set. Okay, so now we want to count how many values are there. So this is the counting command actually, length of Q. So length of Q would already count that how many elements are there in this particular command. Okay, so this would be your length of your for loop. Fine.
Yes, sir.
Yes, sir.
Now, after that, what you will do, you come back to here again. So once you have your Q, so once let's say iteration 1, so you can put maybe your new variable here, let's say Q1 I would be equal to your Q bracket I. Is it fine? I am means that I am running the a for loop in which I am calculating Q1, and for I equal to 1 it is getting inserted value from this Q vector जहाँ से first value को read कर लेगा वो. So I am storing the Q into a new variable Q1. In place of putting a same value of Q, I can do that also, but I generally don't like that at first place. Okay, so I will
Yes,
get
sir.
Q1. Now once I have the Q1, I can go for these expressions. Once I know this RE, so I can reach to these lines. These commands I can put here now. So I can put here REI. हर जगह मैं I लगा रहा हूँ only. And at this place I can put now my Q1I, right? Now I have here Q1I. Fine.
Yes, sir.
How? Okay, so now this RE will be calculated. Once I know the RE, I can calculate my FI. So सब जगह मैंने I लगा दिया only. That's so high here also you command also. With this would be with the if command actually. So this also work in the MATLAB is work as it is only. So this would be before that only. Before this only, if RE this is not the sign actually here. So in MATLAB it would be equal and this command here, this one, this command will work in the MATLAB. Okay. So till then you will calculate means Fi. So if this is true, then it would be calculated. If this is not true, so you have the next choice is the else command. And else command, you will just have this choice only because first choice has gone away, right? So else ke baad you have this only. If that is not true, the automatically your program will go to here.
Yes, sir.
Now think how to calculate this. This is a again what you have here. You have to write it so that your Fi can be calculated. So you have to take out the root from here. So you have to mean the square it first. So if you will square it, so you can taking out the root in that way. Now then this root will go away from here. So this root will go away. Now you want to make it ulta. So you can make it the inverse of that. So you can make this 1 upon this only. So this would be your F actually. So this is 1. Now this would be your Fi. Fine. So this way you will calculate your Fi from this Holland correlations, and that is the end of your this if loop. If loop का end हो गया यहाँ पे. So you it means you have calculated now Fi. Fine.
Yes, sir.
By this if
Yes, sir.
command you have the. After that what you need. I have to go with this one actually, right? So I have to calculate this. So Fl upon D. So I will calculate this now here. This is the head loss. So you can say maybe you can say delta H if you want a command here. So delta H is equal to this, right? So you got the Fi from previous one. You have L, you have D, you have this, you have this is your Q1I, right? Yes or no?
Yes, sir.
So this
Yes,
would
sir.
be calculated from your delta H. Now you have to check this calculated delta H or delta H चाहिए कितना आपको Z1 minus Z2. Yes or no?
Yes, sir.
That much you need. So now you have to check that now you have to find this is H calculated or you can say HL कह सकते हो आप इसको if you want to give a name out. Let's say capital HL आपने name दे दिया इसको. Now you want to calculate difference. Let's say you want to calculate difference delta. So delta, so you can say I लगा दीजिए because I like all values to store in my I vector something. So if I calculate this, so I can calculate my HL bracket I minus मेरे पास क्या values है वहाँ पे what I need just a Z1 minus Z2, right? यही मुझे चाहिए, right?
Yes,
This
sir.
much is the delta which I need. This much is being calculated by taking this particular Q or F. Now this is the difference. Now you have to put further a command here that if your delta I, again let's say less than equal to, now you can give the how much correct you want this value, how much correct you want, matlab how much close you want. Let's say you want this, let's say 10 to the power minus 6, so 1e 10 to the power minus 4 laga diya. So means you have the differences at fifth decimal places only. So this is what you have here, right? So आपने इन दोनों का difference, you have fixed a tolerance for that. If this value is equal to or less than that, this I consider as a root, right?
Yes, sir.
Getting the point? Once जब मैंने जहाँ right hand side calculate किया, left hand side calculate किया, if the difference between the two, if it is less than 10 to the power minus 5, it means my calculations are correct. Correct or not?
Yes, sir.
Yes, sir.
Right? So if this is true, then I can say my Q1 equal to, or let's say I can give now a new command here, let's say flow rate equal to just Q1 bracket I. And if that is not true, then if this is not the condition, what would I do then?
Then we'll go for the next iteration.
Yes, then we will go for the next iteration, right? So this is so if this is true, then it will actually put a break command there. Okay, because I want to break my for loop. So if this is true, this will break my for loop.
Yes, sir.
Okay. Else, what you need here, you have to change. What you have to change?
The value of Q.
How would I change? I am changing here, ना? यही change कर, ये मेरा for loop है, right? Correct or not?
Yes, sir.
तो अब आप बताइए क्या करना चाहिए? What should I do? I have to change this new value.
So I plus 1.
Yeah, you can do that way. So you can put here that I equal to I plus 1. Right? Then AND.
Yes,
Then
sir.
this would be AND of the for loop. One AND would be for if loop, one AND would be your man for loop. Fine?
Yes, sir.
So
Yes,
this
sir.
would continue. So this calculation will continue. This would be a iterative process. And once both would become equal, that would be your flow rate. Is that fine?
Yes, sir.
So this way you would always calculate the flow rate when you will design a gravity flow or any pipeline where you know the elevations and all this. Or let's say somebody has said this is the maximum pressure drop, ये pipeline का diameter है, now you tell me what to do. How much would be the flow rate? Okay, because there you have two unknowns. One is flow rate, one is your friction factor. You cannot fix either of them. So you have to fix them where they will fix up themselves. Is it clear to all of you?
Yes, sir.
So this is the
Yes,
first
sir.
part of this problem, which will solve separately, just to calculate the flow rate. Okay.
Yes, sir.
After that, once you have calculated Q, so you have now Q. This is your final Q will go into this particular pipeline. Now next part there, what you have. Now you want to calculate here that what should happen in this particular segment. Is यहाँ पे जो parallel connections है, what will I do in this particular part? So I will write the head loss equation in line 1, line 2, 3, 4, 5, and 6. So can I write those equations for that? So Let me write it in a different place. So this is for this part. So same way I can copy this from here. So another part is there. I want to write same equations for the different one actually. So this now we have those pipelines which are parallel actually. Can you see these lines? These pipelines, line 1, line 2, line 3, 4, 5, and 6. These are parallel pipelines. So in that case, we only know that pressure drop in line 1 would be equal to pressure drop in line 2 because all of them are connected at a single common point, right? So we can write pressure drop
Yes, sir.
calculation in line 1, line 2. So that's what I am going to the right here only. So I can calculate that HL1 would be equal to your HL2 would be equal to your HL3 equal to your HL4 would be equal to your HL5 which will be equal to your HL6. Right? The head loss in line 1, line 2, line 3, 4, 5, 6 are equal actually. All of them would be calculated by this single expression here. F L upon D V Q1 square upon 2GT. Now we can write individually for each of them. So if you want to write individually for that next line, so you can write here for if you want to write for 1. So let's say you will get 1 here everywhere. So this is for line 1.
Yes, sir.
So let me finish it. I hope you people might be finding it something interesting, not boring.
Yes, sir.
Fine. So this is 1. Now you can write same thing for line 2. So you can change it by 2. So that way you can write for all 6 pipelines you have there. ये सब हो जाएगा,
Yes, sir.
right? Once you'll have this, now Q1, Q2, Q3, Q5, Q6, all of them are your flow rate. Now, can be so we can write in terms of let's say some particular flow rate. So because there the one more thing is coming to you that Q. Your Q is how much now? Q1 plus Q2 plus Q3 plus Q4 plus Q5 plus Q6 because जो आपका Q आ रहा था man which you have calculated previously it's it is the only thing which is going on these pipelines. Yes or no?
Yes,
Yes,
sir.
sir.
Right. So this
Yes,
what you
sir.
have here. So now that is the part. Now you have this. So now we can write. Let's say आपने Q2 को you have write in terms of Q1. Q3 also you have to you have write in terms of Q1. Q4 also in terms of Q1. Q5 also in terms of Q1. Q6 also in terms of Q1. So you can write all of them in terms of Q1. Take 2 at a time. Let's say line 1, line 2. From there you are finding the means expression of Q2. Line 1, the line 3. From there you are finding expression of Q3. Then Q4, then Q5, then Q5, then Q6. Right? You can get all of them in terms of Q1. Fine.
Yes, sir.
Yes, sir.
After that, you substitute all of them here into this equation. So you will get now here you will get Q1 and then with the variables of F1. F1, F2 are the unknowns. The rest of things are the known to you. And Q is already being calculated. So this is how good calculate is your Q1. Once Q1 is calculated, you Q2, Q3, Q4, Q5, Q6 would be calculated. Now before that is this part. that first you are calculating this thing, this condition need to be satisfied. This condition need to be satisfied first. At what condition it is getting satisfied this way? So what can you do for that? Again, you are starting a Q, or let's say friction factor. या तो आप फ्रिक्शन फैक्टर से स्टार्ट करिए और Q1 से स्टार्ट करिए. जस्ट स्टार्ट ए Q1. सो आपने Q1 को लिया आपने. लेट्स यू हैव टेकन ए गेस ऑफ Q1. Q1 आपने स्टार्ट किया. Okay, you have taken a value of Q1. Once you know the Q1, then Q2, Q3 can be calculated, right? So in pipe 1, you have taken a Q1. Now once you have Q1, you can calculate your F1, yes or no? ये तो calculate किया जा सकता है.
Yes, sir.
Yes, sir.
Once F1 is can be calculated, now can I calculate this F2? Anything? Any guess? I took a value of Q1 and started calculated for this. So if I know Q1, I can calculate F1, no doubt in there. Now in this second part here, this one I want to calculate head loss in pipeline 2. So here I have two variables. One is Q2, one is F2. If I equate these two, what will I get from here? So I have two unknowns, Q2 and F2. How to get rid of this? Hello?
Sir, writing Q2 in terms of Q1.
Q2 in terms of Q1. So then again you will get F2.
Yes, sir.
Yes or no?
Yes, sir.
So what to do for that?
Yes, sir.
Can you think what to do for that? Or can we start in a different way? In a different way, can we start in different way? Let's say you have taken, in worst case, you have taken, let's say, friction factors in all the pipelines are equal. I'm just taking for time being. Can we take that? Let's say starting case, we have taken friction factor in line 1, line 2, line 3, everything are same.
So then we'll have only one variable. And then we can.
Then we'll have only one variable, right?
Yes, sir.
Okay, so from that, we can calculate our Q1, Q2, Q3.
Yes, sir.
Yes,
Right?
sir.
Yes.
That is the starting phase only starting phase. हमने कुछ लिया, F लिया, and just taking F is same. We did some calculations. उस calculation के बाद we got now Q1, we got now Q2, Q3, Q4. We got everything. Correct?
Yes, sir.
Yes, sir.
Now for that, let's check this relationship if it is the satisfied or not. यदि ये satisfy कर देता है somehow, it means whatever we have taken is correct. No need to do further calculation for that. Okay?
Okay, sir.
No need to do any further calculation for that. Suppose this is not fulfilling this condition. Now you have value of Q1, Q2, Q3, Q4, right? take those values, now calculate your F1, F2, F3, F4, F5, F6. You can calculate because now you have the flow rates.
Yes,
Correct or not? You have now flow rates. Calculate your F1, F2. So once you have calculated now new value of the F1, the F2, calculate again your flow rate and satisfy this again further. And this thing will keep on continue till your this continuity equation is satisfied. So that would be your end of the calculation of these parallel pipelines. So it will tell your all flow rates.
So can you
So
please explain the last part again?
yeah, so I can show you because have here direct program of that only. On paper, I have not wrote the all equations here. So I just have taken in the different way. So what you have first thing, this one from here, yeah, I think for this one. Yeah. So what you have here, so I have taken a flow rate as a trial values because either you can take Q and check for F and all this calculate it. So I take it F. F is friction factor. Okay, F you have a friction
Yes, sir.
factor. So friction factor, you know that the highest possible value could be 0.1, 0.01 actually, 0.1 be too much high hota hai. As you say that your Darcy chart actually, Moody chart, in that way highest friction factor comes to be 0.01 something. So I have taken 0.1. In between of that, I have the started from here. This is the least value. I am changing every time by this and I will reach till here. So I have taken F. For F, I can calculate your Q here. Once I know F here, I can calculate Q from your Z part. You have the delta Z divided by you have your delta Z equal to F L upon D B square upon 2G thing, right? So from there, I can calculate the Q. I have the
Yes, sir.
F, now I can calculate Q. Once I know the Q, I can calculate now RE. So from the RE, I can calculate now F. If RE is less than this, I can calculate this, else I have calculated RE is this. Now I am calculating the difference between the friction factor, what I have considered, what is coming from these calculations. If that error is less than 10 to the power minus 6, so that is my root only, right? That's what is my root, so I got flow rate. So same thing I explained to you for flow rate. We have taken there as a flow rate as a variable and we calculated it and we will continue till we get the continuity is the satisfied, right? This is first part. Okay.
Yes, sir. Yes, sir.
Second part, you have all these pipelines. So let's say what I did here. So you have here. So first thing I have considered, as I told, each pipeline I have considered friction factors same. And all of them I just consider for time being one. One to kabhi hota nahi hai. So just each for calculation I have taken everything is one here. Okay.
Yes, sir.
So
yes,
I have formula for Q by doing the head balance from the individual file. So I have the formula for Q equal to Q1 plus Q2 plus Q3 plus Q4, Q5, Q6, right? Correct or
Yes,
not?
sir. Yes, sir. Yes, sir.
So I have that formula. So I have the substituted everything here. So from here I will get Q1, then I will get Q2, then I will get Q3, then Q4, Q5, Q6, and Q7 is the another variable, the total of all flow rate. That's what we have Q only, right?
Yes, sir.
ठीक है.
yes,
So ये Q7 आपका Q ही है. So I am taking ये Q7 क्योंकि I am calculating Q1, Q2 individually. उनका total मेरा Q से satisfied तो करना चाहिए, right? Yes or no?
Yes, sir.
yes,
Right. So once I have Q, I can calculate now flow rate. I can calculate velocity now. Velocity, sorry. So velocity v1, v2, v3, v4, v5, v6, v7.
Yes, sir.
Once I know the velocity, I can calculate the Reynolds number.
Yes, sir.
Reynolds number जब मेरे पास है तो I can again calculate the friction factor. Right? Friction factors for all the pipelines, all 6 pipes. Each time I have two conditions. If less than equal to this, I can calculate this, else I am calculating from here. So each pipeline, I have this command. This is for pipeline 1. This is for pipeline 2. This is for pipeline 3. This is again pipeline 4. Then this is 5. This is for 6. And this is for 7. Okay? ठीक है?
Yes, sir.
सारे पाइपलाइंस के लिए मैंने फ्रिक्शन फैक्टर कैलकुलेट कर लिया. Once I know friction factor, I can again calculate Q1, Q2, Q3, Q4. Okay, now I have the new value of the friction factors. Correct or not?
Yes, sir.
Yes,
So
sir.
I got all now the updated Q. Updated Q from the here. So updated Q now I am cross-checking again by putting in the expression of Q1. And now I am calculating the delta. Difference in flow rate. जो मेरा flow rate calculated है, जो मेरा actual flow rate is Q. I'm just finding the difference. Absolute means I'm not considering sign. I'm considering absolute values because sometimes the difference could be minus 10 to the power minus 6. Sometimes could be plus 10 to the power minus 6. But my answer both the way is correct, right? So therefore, I am taking absolute the difference. So if this is the valid actually, so I am putting a condition here. If this flow rate is the less than 10 to the power 19, I put actually here. Up 10 लगा दो, 6 लगा दो, जो आपको ठीक लगे. Then I have the flow rates. This is my flow rates in all these pipelines. And that's what is my end of the calculation of this file. These are the head losses. You wrote for head losses, again you calculate the velocity. I have also calculated number of the iterations, kitne trials mein calculation hua. And that is the end of the flow rate. That's part of this loop part.
Yes, sir.
ठीक है? थोड़ा बड़ा प्रॉब्लम है, so maybe आप primarily आप चाहो तो बाकी पाइपलाइन हटा दीजिए. Just take maybe 2 pipeline. अब 2 के लिए बना लीजिए पहले, right? Because
Okay,
for two it will be convenient to you first, right? कि 2 को आप हैंड से भी क्रॉस चेक कर सकते हैं ना इजीली.
Yes, sir.
Yes,
फिर
sir.
जब आपका 2 का चल जाएगा तो बाद में तो आपको फॉर लूप में ये पेस्ट ही करना इन ही करना है. सो दैट वोंट बी ए बिग प्रॉब्लम एक्चुअली. सो दिस वुड एंड हियर द कैलकुलेट ऑफ फ्लो रेट. जब आपका कैलकुलेट हो गया फिर आप पंप लगा दीजिए. आपको ईच पाइप में एक पंप लगाना पड़ेगा टू कंपनसेट दैट हेड लॉस ना. So you can put a pump here, pipeline 1, pipeline 2, pipeline 3. So pump power is how much? QH rho G is the QHL rho G, right? So that is the pump power, power of the pump. Okay? So if you
Yes,
want
sir.
to put
Yes, sir.
power pump in the each pipeline, so that much head loss you have to compensate only. So that is the flow rate in pipe. Q, this is the head of the pump, multiplied by density, multiplied by G only, rho G actually. So you can calculate here, right? You can calculate pumping power of each pump. Pump लगा रहे थे आप. Now you want to have a single pump at point 2, so add them up, all powers. So you can add them up, you will get a power of a single pump, and that's what your final calculation answer says. So you are getting this one only. ठीक है? So try to do it in that way.
Yes, sir.
So this way you can complete your designing of the gravity flow butterfly. start calculation in that way. Fine.
Yes, sir.
Yes, sir.
Okay, so we will do the L means root finding thing tomorrow. Then we'll end up here then.
Okay, sir.
Sir, when will be our test?
Let that girl come now. So उसको भी तो देना बेचारे को, right?
Yes, sir.
So let her come and then we will fix up actually.
Okay, sir.
ठीक है?
So please share today's lecture.
Yeah, sure. I would say.
Okay, sir.